Good afternoon. So today I will be continuing with the problems on support reactions. Okay. So I think I have completed 6 problems. So let me take up the next problem, that is, I guess it's 7th one. Okay. So we'll continue with the 7th problem. Determine the reactions at the supports for the beam shown in figure. The question is saying determine the reactions at the supports, determine the reactions at the supports for the beam shown in figure, beam shown in figure. For the beam shown in figure. So the beam that they have given is like this. So it is little bit different when compared to the problems that we have already solved in the last class. So they have given the beam like this. Okay. So this they have given it as A portion, and at A, so it's a hinge support. Next, this they have called it as B portion, and here they have given the roller support. Okay. So that is B portion. Now this particular junction they have called it as C portion, and the last one they have called it as D portion. So when compared to the previous problems that we have solved, this problem is completely different. I will be telling why. So they have given an UDL like this. So the value of UDL is 20 kilonewton per meter. So the span also they have given it like this. So the span they have given it like this. So this is 1 meter, this is 1 meter, this is 1 meter. So totally the span of one particular beam is 3 meter. So next, similarly, they have given one more. So here they are having, they have given an inclined force of 10 kilonewton, and the angle at which it is inclined, they have given this as 60 degree. They have given that as 60 degree. So this is what they have given. So this distance is 1 meter and this distance is 3 meter. Okay. So now the thing is, this is 1 meter and that is 3 meter. I want you people to concentrate on this. Okay. So what we need to do here? So now observe, there is a AB beam. So this is one particular beam. There is one more beam, that is CD beam. So we need to write the free body diagram two times. For AB beam one time and for CD beam another time. So I will be doing that. Okay. So now observe here. So first let me write the free body diagram for AB beam. Okay. So now let me write it at a lower span. Okay. This is A, this is B. Now at A, what is the type of support we are having? So the type of support that we are having at A is, this is RA. Okay. There is one more, that is HA. One is RA and one more is HA. So at A it is a hinged support, therefore one is RA and one more is HA. Okay. Next we are having an UDL load. So how to convert the UDL to point load? So UDL to point load. So UDL2 point load. So it's W into L. So what is the formula? I mean, what is the value of W? It's 20 kilonewton per meter. And what is the span at which it has been distributed? 1 meter. So don't you think that it's 20 kilonewton? Next, at what distance it acts? It acts exactly at center. So it's 20 kilonewton. This is 0.5 meter. This is 0.5 meter. I am concentrating only on AB beam. CD beam, I will be writing it a little bit later. So now there is one more support. So that is B, and that too it is roller. For a roller support, will you people accept it? There will be only one reaction, and that too in the upward direction. Yes or no? So now we are having a roller support here. We are having a roller support. It is also a kind of support. I am concentrating on AB. So this roller will hit like this. So due to which, observe here, so there will be a reaction from the beam. So that reaction will be acting in upward direction. Don't get confused. Whenever you consider this, okay, this beam hits that in the above direction. Because I am writing the free body diagram of the beam, concentrate on the beam. The beam hits the roller. This is a roller support. The beam hits the roller in the above direction. Therefore, there is a reaction from the roller, and that will act in downward direction. So that I will be calling it as RC. Any other thing that comes for AB beam? So that's it. So now let me move on with the free body diagram of CD beam. Let me move on with the free body diagram of CD beam. This is completely a different kind of problem. Okay. So now for CD beam. So at C, we are having a roller support. So concentrate on the beam. The beam hits the roller in downward direction. Therefore, there is a development of reaction in upward direction. So one thing is sure. Whenever you are having a roller like this, okay, so one force needs to be acting in upward direction and one force needs to be acting in downward direction. Please concentrate on that. Okay, so what I will be doing is, this is also RC and this is also RC. Both values should be same. So next, we are having a 10 kilonewton inclined force. Whenever you are having an inclined force, you can't, you don't have any particular formula. So I need to resolve that into exactly horizontal and exactly vertical. So I think you people know that. So the inclined force with which line it is making an angle, that is cos. So the vertical one will be the cos. So it is 10 cos 60 degree. Okay, next there is one more. So horizontal, it is 10 sin 60 degree. Okay, so I know the span. This is 1 meter and this is 3 meter span. Yes or no? Now, don't you think that RD, D support is a hinged support. For hinged support, you people will have two reactions. One in the vertical direction and one more in the horizontal direction. That is HD. So if you know how to write the free body diagram for this, so now you can easily solve the problem. The same thing. Apply equations of equilibrium. Apply equations of equilibrium. So let me apply the equations of equilibrium. So now, using equations of equilibrium for, now the thing is, you are having two beams. So one is AB and one more is CD. So which particular beam shall I consider first? Okay, which particular beam is having less unknown? Consider that first. Okay, so now let me take CD. How many unknowns are there? So RC, one unknown. HD and RD, so two unknowns. Totally 3 unknowns in CD beam. Let me go with this A. Okay, so in A, observe. HA, 1 unknown, RA, 2, RC, 3, RB, 4. So in CD beam 3, in AB beam 4. So which one shall I consider? So first consider the free body diagram of CD. So using equations of equilibrium for CD portion. Okay, so now as usual, first one, sigma H is equal to 0, rightward direction positive. Okay, so now Only I am concentrating on CD beam. So in CD, how many horizontal forces are there? Observe here. So there is an horizontal force which is acting in leftward direction, so negative. And what is that value? It is minus 10 sine 60. Minus 10 sine 60. Next, there is one more horizontal which is acting in leftward direction. So it is minus HD is equal to 0. So HD is equal to, so it will come negative value. So what is the value of HD? It is minus 8.66. It's minus 8.66 kilonewton. So don't write negative. So what I will be doing is, it's 8.66 kilonewton. Negative means, don't you think that it acts in leftward direction? So what it is indicating? Sorry, not leftward direction. Already we have taken it in the leftward direction. So as it is negative, so you should say that it is acting in rightward direction. Don't get confused here. Already in the starting, we were not knowing, so we have assumed that it might be acting towards the beam. But answer is indicating negative. It means that it is not acting towards left, it is acting towards right. Because usually what happens is, as per our sign convention, so leftward we will be taking it as negative, rightward we are taking it as positive. Yes or no? So now final value is revealing that already you have taken it as leftward direction, but answer is indicating it should not take in leftward direction, it should act in rightward direction. So that is the meaning of this. Second one. Let me go with sigma V is equal to 0, upward direction positive. So for CD beam, what are all the vertical forces? We'll see. So RC, it is acting in upward direction, so positive. So next, there is one more force which is acting in downward direction. So it is minus 10 cos 60. So next, anything else? Yes, plus RD. Plus RD is equal to 0. So for RC plus RD is equal to 10 cos 60. For time being, let me call this as equation 1. So let me go with the last one, that is moment about certain point. Now the supports are at C and D. So at C one support is there, at D one support is there. Okay. So now about which particular support we need to take the moment? Where there are more unknowns. So don't you think that at C there is only one support. Sorry, there is one reaction. So at D we are having two reactions. So therefore I will be taking the moment about D point. So clockwise direction positive. Yes or no? So now let me hold a finger about D point. Now this RC, observe here, this RC. So it needs to go and touch it in clockwise direction. It needs to go and touch it because I want moment about this point. Yes or no? Let me extend a line of action in which the direction of the force is acting. Here I want to take this force which is acting in this direction, extend a line of action. Don't you think that this force needs to go and touch it in clockwise direction? So therefore RC into 4 meter. RC into 4 meter. Next, what about this? So this force, it is acting in downward direction. So let me extend a line of action. Don't you think that this force needs to go and touch this line? If it goes clockwise, it is the longest distance. I want the shortest distance, like this. So it's anti-clockwise. So minus 10 cos 60. It's minus 10 cos 60. Minus 10 cos 60 into 3. So what will happen to this horizontal force? Don't you think that where I want the moment and this force are in the same point? So forget about this force. Okay. Next. This HD also gone because it is acting in the same line of action where I want the moment. So now we are left out with the last one. Okay, so where I am taking the moment? So at D only, right? So as I am taking at D, RC into 4, next minus 10 cos 60 into 3 because it needs to go and touch it in this direction. So that's it, because this also becomes 0 because at this particular point it's in the same line of action. Okay, so these two forces will also become 0. So finally, so what we get is the value of RC is 3.75 kilonewton. 3.75 kilonewton. Now substituting RC value in 1. So what I will be doing is from 1. So I can say that, observe here, RC value I know, it's 3.75 0.75 plus RD, that only I need to calculate, is equal to 10 cos 60. 10 cos 60. So RD final value is the value of RD. It's 1.25 kilonewton. It's 1.25 kilonewton. So now for this particular beam CD, okay, so we have calculated RC, we have calculated HD, we have calculated RD. But in the previous classes only I have told you people, yes or no? So what is that? So whenever at a support you are having two values, you need to calculate the resultant. So let me calculate the resultant. Resultant at D. Resultant at D. I will be calling it as RD dash, which is nothing but equal to RD square plus HD square. Okay, so what is the value of RD? It's 1.25. Don't consider negative sign anywhere. Okay, so now what is the value of HD that we got? 8.66 square. So what is the value of RD dash? So the value of RD dash is 8.74 kilonewton. 8.74 kilonewton. Now let me calculate the direction. So it is given by tan inverse of vertical force. So it is RD divided by HD. So the value of RD is 1.25. The value of HD is 8.66. Yes or no? So what is the final value? So alpha value is given by 8.21 degree. 8.21 degree. So any doubts in this? So we have completed with the CD beam. Now still we need to go with the AB beam. So for that reason what I will be doing is, observe, let me rub this portion. Okay, so here let me rub this also. Now can I use this? Using equations of equilibrium for, I will be going with AB beam. I will be going with AB beam. Observe, let me rub all these things. Let me not confuse you people. Okay, so same thing. So applying equations of equilibrium for AB beam. Okay, so let me apply for AB. So AB portion over here. So sigma H is equal to 0. So we are having only one particular force here, HA. So HA will be equal to 0. Okay, this we got it. Next, let me go with sigma V, vertical forces, RA. So it is acting in upward direction. So positive. Okay, next, minus 20 kilonewton, which is acting in downward direction. Okay, next, we are having RC value. It is acting in downward direction. So minus, but we know the value of RC. So as it is acting in downward direction, just mention the negative sign. But what is the value of RC that we got? So it is 3.75. So you write that. It's 3.75. So next, if we come over here, so it is upward acting RB. So which is nothing but equal to 0. So finally can I say RA plus RB is equal to 23.75. Let me call this as 1. Already I have called in the previous equation as 1. Now let me call this as equation 2. So now let me move on with the next one. Where shall I take the moment? Where shall I take the moment? Now be careful. As usual, where we are having more unknowns, at A. So let me take the moment about A point. Let me take the moment about A point. Okay, if I want the moment about A point, next, this force 20 kilonewton, don't you think that this force needs to go and touch it in clockwise direction? So 20 into 0.5. So it's plus 20 into 0.5. Okay, next, there is an RC that is 3.75. This also needs to go and touch it in clockwise direction. Now be careful, this is 1 meter span, this is also 1 meter span. So this RC needs to go and touch it in clockwise direction. RC is 3.75. 3.75 into 2. So plus 3.75 into 2. Next, I want moment about A point. There is one more. So RB, which needs to go and touch it in anti-clockwise direction. So minus RB into 3. Minus RB into 3. So finally, after solving, so the value of RB that we will be getting here is, so it's 5.83 kilonewton. It's 5.83 kilonewton. So we got the value of RB. So soon after getting the value of RB from equation 2, substitute it. RA only I need to calculate. RB value just now we have calculated it. Okay. Next is equal to 23.75. So finally RA value will be equal to, so finally RA value will be equal to 17.92 kilonewton. 17.92 kilonewton. Now, even though at RA we are having two forces, but the value of HA is 0. So there is no need to calculate the resultant. So this is how we need to solve the problem. So any doubts? So observe here. So in all the previous problems that we have solved, so what we were doing, so they have given only a single beam, so only one time we were applying the equations of equilibrium. Yes or no? So now here they have given two beams. So for each beam we need to apply the we need to write the free body diagram, then we need to apply the equations of equilibrium separately. Any doubts in this? So now let me move on with one more problem. Okay, the same kind of a problem. So now let me take up one more. Let me rub this. I think 8th problem, I guess. Okay, so now let me continue with the next one. The question is a little bit different. Determine the reactions at the support and the force in the flexible link BC. Determine the reactions at the supports and determine the reactions at the support and the force in the flexible link BC for the figure shown below. For the figure shown below. For the figure shown below. Okay, so the diagram that they have given is like this. So this is one beam. There is a flexible link BC like this. There is one more like this. Okay, so now at this junction they have given it as a hinge support. This is A. Okay, throughout this particular beam we are having an UDL. So the value of UDL is 1 kilonewton per meter. Okay, so this is B, this is C. BC is the flexible link. It means that tension will be acting in that. I will be explaining it. So next, in this portion also we are having a support over here. So be careful. So it's a roller support that they have called it as D point. At the last, it's again the hinge support. So they have given it as E. And they have provided a point load like this. They have provided a point load like this, not exactly at the center, but at some distance. So what is that particular value? 10 kilonewton. So it's 10 kilonewton. So now let me mark the span for all these things. So now let me mark the span. So the span for the first beam is 5 meter. So here they have given it as 3 meter. Okay, as the diagram is not as per the scale, so even though it is 3 meter, it's very small. That's okay. So now this is 1 meter and this is 2 meter. Okay, here also the same thing. If I want to solve any problems in support reaction, so first I need to draw the free body diagram. So let me draw the free body diagram. But it's not a sub-separate beam, so what I will be doing here is, so AB, this is BC, this entire portion, let me write it at a time. So now, A portion, we will be having two forces, because two reaction because of hinge support. So it is RA, the vertical one, sorry, the horizontal one is HA. Now it's a UDL. So what we need to do for UDL? So to convert UDL to point load, so the formula is W into L. So the value of W is 1 kilonewton per meter into, the span is 5 meter. So meter get cancelled. Finally we are left out with 5 kilonewton. Okay. So now, so 5 kilonewton where it acts? It acts exactly at the center. So this is 2.5 meter. This is 2.5 meter. Okay. So now be careful. They have told in the question that BC is a flexible link. So what do you mean by flexible? Flexible means tension will act. So how to mark the tension part? Observe here. If I consider this portion, so this is B portion and this is C portion. So from C point, so there will be a pulling force. So from B point, there will be a pulling force. So this is how we need to mark the tension. Please remember, whenever they tell us that it's a flexible link, so we need to mark the T, tension. From both the point, you need to show the arrow mark in a stretching manner. So now we are having a roller support. So for roller support, one reaction, that too RD. So there is 10 kilonewton point load. Let me mark as it is. So this is 3 meter, this is 1 meter and this is 2 meter. So at T portion we are having two supports. Okay, so one is RE and one more is horizontal, that is HE. Usually the horizontal force I take towards the beam. Final answer will reveal us whether the assumption is correct or not. So this is how you need to write the free body diagram. Okay, so now observe. I can't consider the entire beam and apply the equations of equilibrium. Here also I will be doing the same thing. First I will be considering the AB portion. Next I will be considering the CE portion. Now I want you people to tell me whether shall I consider AB portion or CE portion. So AB portion, how many unknowns are there? We'll see. Okay, at AB portion HA, RA and this T. So 3 unknowns. Next, let me consider the CE beam. So this one T, this RD, next RE and HE, totally 4. So now what I will be doing is, instead of going with CE beam, I will be going with AE beam. So what I will be doing is, consider AE portion. Next, using equation of equilibrium, okay. So consider AE portion using equation of equilibrium. Okay, as usual, first one, sigma H is equal to 0. Rightward direction positive. For AB portion, we are having only one horizontal force and that too it is HA. So HA, so it is acting in rightward direction. So there is only one force, so it is 0. Second one, sigma V is equal to 0. Upward direction positive. Okay, so upward direction positive means RA is acting in upward direction, so positive. Next, we are having a vertical downward force which is acting in downward direction. So minus 5. Next, we are having T which is acting in upward direction. So plus T is equal to 0. So can I say RA plus T is equal to 5? Let me call this as 1 for time being. Now, I need to take the moment about certain point. So it is sigma m into value. Okay. So now what I will be doing here, observe. So as at this particular support we are having two unknowns, let me take the moment about this point itself. Okay. So now don't you think that this 5 kilonewton clockwise it needs to go. So 5 into 2.5. So I will be taking moment about A point. So clockwise direction positive. So it's 5 into 2.5. Okay. So next, observe here. I want moment about this point. Next, a tension force is acting in upward direction. This force needs to go and touch it in anti-clockwise direction. So minus T into 5. Minus T into 5 is equal to 0. So finally, what will be the value of T? So finally, the value of T will be 2.5 kilonewton. It's 2.5 kilonewton. So we have calculated the value of T. Now from equation 1. From equation 1. So RA only I need to calculate. So T value just now we have calculated, it's 2.5 is equal to 5. So don't you think that RA is also 2.5 kilonewton? So now we have completed with the AB portion. Now let me move on to the CE portion. Consider CE portion. Consider CE portion. Same thing using equations of equilibrium. Let me not write it directly. Sigma H is equal to 0. Rightward direction positive. Okay. So now how many horizontal forces are there? There is only one horizontal force, and that too it is HE and it is acting in leftward direction. It doesn't matter minus HE is equal to 0 or nothing but equal to HE is equal to 0. Yes or no? Next, let me go with the second one. Okay, so that is sigma V is equal to 0, upward direction positive. Upward direction positive. Okay, so now observe here. So we already know the value of T, that is 2.5. Just observe the sign. The arrow mark is acting in downward direction. Downward direction means negative. Minus, what is the value of T? It's 2.5. Now, there is RD force which is acting in upward direction, so positive. Okay, next, minus 10 kilonewton which is acting in downward direction. Next, plus RE which is acting in upward direction is equal to 0, or else I can say RD plus RE. So if I transfer all those things towards that side, this will be like this. Let me call this as equation 2. So which is the third equations of equilibrium? So sigma m about some point is equal to 0, clockwise direction positive. Now in CE portion, okay, so here we are having one force, here we are having two. So let me take the moment about E point. I will be taking the moment about E point. Observe here, about E point I want. So this T which is acting in downward direction, observe here, I want moment about this point. The force is acting in this vertical direction. Let me extend a line of action. Don't you think that this force needs to go and touch it in this direction? If it goes in this direction, it will be the longest distance. So this force needs to go and touch it in this direction, anti-clockwise. So minus T into 6. What is the value of T? It's 2.5. So minus 2.5 into 6. It's minus 2.5 into 6. Okay. So now, let me go with this. So this RD, it needs to go and touch it in clockwise direction. So plus RD into 3. So plus RD into 3. Okay. So next, there is one more force which is acting in downward direction. This force needs to go and touch it in anti-clockwise direction. So minus 10 into 2. Minus 10 into 2. So I think that's it. Because at E portion only I am taking the moment, these two forces will become 0. Okay, so now is equal to 0. Then the value of RD after solving. So what is the value of RD? So the value of RD is 11.66 kilonewton. 11.66 kilonewton. So now if I substitute this particular RD value in 2, so what will happen? So RD value I know, so it's 11.66. So from 2, 11.66 is the value of RD plus RE is equal to 12.5. Then the value of RE. So the value of RE is equal to 0.9 kilonewton. It's 0.9 kilonewton. Now even though at A point we are having two forces, HA was 0. So no need to calculate the resultant. Here also at E, even though we are having two forces, HE is 0. So there is no need to calculate the resultant. Okay. So this completes the problem. Okay. Any doubts in that? Now we'll move on with the last problem. Observe. The same thing. Everything is same. A slight change. So let me rub this. I think this is the 9th problem, I guess. Okay. So now find the reactions for the support. Find the reactions of the supports for the beam shown in figure. For the beam shown in figure. So now the diagram that they have given us as usual. So there are two beams. So for this particular support they have given the hinge one. So here they have given the roller. Okay. So now for the half of the portion they have given the UVL. Be careful. So they have given the UVL. Okay, the value of UVL that they have given is 2 kilonewton per meter. 2 kilonewton per meter. Next, they have given at 1 meter, they have given one more point load. So that is 5 kilonewton. So this is 1 meter span. Next at 1 more meter, okay, they have given 5 kilonewton like this, okay, and this particular distance, this vertical distance. So this is also 1 meter, this is also 1 meter. So this vertical distance they have given it as 0.5 meter. Next, they have given one more. So this is also they have given it as 5 kilonewton. And this vertical distance also they have called it as 0.5 meter. And this particular distance, this they have given it as 3 meter span. Okay. So now we are having one more beam. Observe here. So we are having one more beam. This 3 meter I will be writing it here itself. Because they have given one more beam. So I need to write it over here. So that's why. Okay. So now here they have given a roller support. Here they have given a roller support. Okay. This is A portion. This is B. This is C. And here it is D. And the last one is hinged. Okay. So they have given this as 3 meter span. Already we know it. So this is 3 meter span. Next, at 2 meter, there is one more. At 2 meter, they have given a pure moment in anti-clockwise direction. So it's 3 kilonewton meter. And the distance that they have given is, this is 2 meter and this is 1 meter. So please be careful. So as usual, we are having two beams. So one is AB beam and one more is CD beam. Let me write the free body diagram. Same procedure, write the free body diagram, apply equations of equilibrium. Okay, so first let me go with, so AB beam, and let me write the free body diagram of this. So AB portion, okay, so at A we are having vertical and as well as horizontal because it's a hinge support. Next, at 1 meter span, okay, so we are having a load, so it's 5 kilonewton. So this is 1 meter. Okay, here also we are having one more. So what we need to do here is, let me write it as it is for time being. This 5 kilonewton. So this span is 1 meter, this span is also 1 meter, this is 0.5 meter. So here also the 0.5 meter. So it's 5 kilonewton and this particular distance is 0.5 meter. Now how to convert this UVL? So observe here. So UVL, 2 point load. Yes or no? So what is the formula? So it's WL by 2. So what is the value of W? So it's 2 kilonewton per meter into, for what span it has been spread? So it's 3 meter. So by 2. So totally it is 3 kilonewton. So at what distance it is acting? From 90 degree side. From 90 degree side. So it will act at a distance of L by 3. What is the span? So it is 3 meter. So 3 by 3, that is 1 meter span. From 90 degree side. Be careful. Okay. So from 90 degree side, okay, it acts at a distance of 1 meter. So 1 meter, so this is 2 meter, and what is this force? 3 kilonewton. So from 90 degree side, L by 3 distance. So we are done with it. Now be careful. As this beam, AB beam, is hitting the roller support in downward direction, there is a development of reaction. So that is RB. Be careful. So we have completed with the, we are completed with the AB portion free body diagram. Now let me move on with the CD portion free body diagram. So CD portion free body diagram, let me write it. So C portion, it's a roller. So one force RC. So now observe here, this CD portion will hit the roller in upward direction. There is a development of reaction in downward direction. One thing is sure. If this is upward, obviously other needs to be the downward direction. Okay, so this span is 3 meter. Next, there is a pure moment. Let me not disturb that. So it's 3 kilonewton meter. So as it is a hinged, so one in the vertical direction RD and one more in the horizontal direction HD. Usually the horizontal forces I write towards the beam. Okay, I usually write towards the beam. Okay, so now let me go. I want you people to tell me which particular portion shall I consider. So now observe here. If I consider the AB portion, how many unknowns? HA, RA, RB, 3. If I consider CD portion, so RC, RB, 2, and here there are 4 totally. So what I want you people to do is, so take AB portion first. So take AB portion first. So let me go with consider AB portion. Consider AB portion using equations of equilibrium. Using equations of equilibrium. Equations of equilibrium. So the first equations of equilibrium is sigma h is equal to 0, rightward direction positive. Yes or no? So now observe. So rightward direction, this one, HA, which is acting in rightward direction. Okay. Any other horizontal forces? So don't get confused here. So yes, we are having one more. So which is that? Observe here. So this 5 kilonewton, don't you think that it's horizontal and it is acting in rightward direction, so positive. So this 5 kilonewton, it is acting in leftward direction, so negative. So one is acting in positive direction and one more acting in negative direction. So don't you think that finally the HA value will be equal to 0? Okay, we got the value of HA. So next, so what is the value of next one? That is sigma V. Let me apply sigma V is equal to 0. Upward direction positive. Okay, so upward direction means RA, which is acting in upward direction. Plus or minus, we'll see. So sorry, minus 5. So minus 5. These two are horizontal, I will not be considering. Next, if I move on, minus 3. Next, RB, it is acting in upward direction, plus RB is equal to 0. So RA plus RB is equal to 8. Let me call this as 1. Now I need to take moment about certain point. Yes or no? The same concept. Sigma m, about which point shall we take? I will be taking about A point only because more number of unknowns. So clockwise direction positive. I want you people to concentrate and tell me. Observe here. If I take moment about this point, so force, this 5 kilonewton, it needs to go and touch it in clockwise direction. So 5 into 1. So clockwise. So 5 into 1. Be careful now. So what will happen to this force? Observe here. This force, I want moment about this point. Okay, don't you think that the force is acting in the horizontal direction? So extend a line of action along the direction of the force. In which direction this force needs to go and touch this line? Clockwise. So 5 into 0.5. Be careful with that. Plus 5 into 0.5. Okay. So now there is one more. So here also a force is acting. So I want moment about this point. The force is acting in horizontal direction. Extend a line of action. This force needs to go and touch it in clockwise. So 5 into 0.5. One more plus. Plus 5 into 0.5. So next, we are having one more. So 3 kilonewton into 5 plus 3 into perpendicular distances 5. Next, there is RB, force into perpendicular distance, minus RB into 6. Minus RB into 6 is equal to 0. So after solving it, the value of RB that we will be getting here is 4.166 or 4.16. So okay, not meter, it's kilonewton. So now substituting this in equation 1 from 1. So from 1, okay. So RA only I need to calculate. RB value I know it is equal to 8. So what is the value of RA? So it is 8 minus 4.16. So it's 3.8. Approximately I am writing it. Okay. So it's kilonewton. So now the thing is, HA value already 0, so no need to calculate the resultant at A. So we are done with this. So we are left out with CD portion. We are left out with CD portion. So now consider CD portion. Let us be fast. Consider CD portion. Again apply the equations of equilibrium. So first one is sigma h is equal to 0. Rightward direction positive. Yes or no? So now, so in CD portion, we are having only one value, minus HD is equal to 0, or finally HD is equal to 0. So now, let me go with sigma V is equal to 0. Upward direction positive. So now, RC value, it is acting in upward direction. Next, this RB value, I know it. So it's 4.16, which is acting in downward direction. So negative, minus 4.16. Okay. Next, it's a pure moment. I will not be considering it here. Okay, next RB. After that, we are having RD, which is acting in upward direction, is equal to 0. So RC plus RD is equal to 4.16. Let me call this as equation 2. Let me take the moment about certain point. No doubt, I will be taking the moment about D point, because two forces are acting at D point. Okay, so I will be taking moment about D point. So third one, sigma MD is equal to 0, clockwise direction positive. Yes or no? I want moment about this point. Observe here, this point I want moment. So RC is acting in this direction, it needs to go and touch it in clockwise. So RC into, this is 2 meter, this is 1 meter. So RC into 6. So RC is plus into 6. Next, this RB value I know it, 4.16. This force needs to go and touch it in anti-clockwise direction. So minus 4.16 into 3. Minus 4.16 into 3. Next, as it is a moment, I need to consider the pure moment. Pure moment is acting in anti-clockwise direction. Minus 3 is equal to 0. So the final value of RC is 2.58 kilonewton. So from 2. So RC I know it, 2.58, RD is equal to 4.16. So finally the value of RD is equal to 1.58. It's 1.58, approximate value. So please do it in the calculator and get it verified. So now here also HD value is 0. Okay, so no need to calculate the resultant. So these are all some of the problems that will come in support reaction. So this completes the support reaction. So in the next class, I will be taking up a new topic in module 3, that is analysis of simple trusses. So for today's session, we'll wind up. Thank you.